general relativity step by step. We've got a nice expression for the Riemann Christoffel tensor R, which I've written in different, R, which I've written in different ways, but we'll try d a b c, and that was equal to Christoffel symbol d a c b, and here I'm using the notation of something comma b equals die the something with respect to die x b. So it's just a shorthand notation, but I just want to be clear that that comma there is an ordinary partial derivative, not a total derivative. Minus Christoffel symbol DAB, comma C, plus, and then the product terms. We've got EAC, DEB, and there's a minus the second term, EAB, DEC. Okay, so we've got this beautiful system here. What I want to do is to talk about the lowered system. So we've got Christoffel A, B, C, D equals G, A, E. All I'm going to do is lower this index D here, but I've got to call it an E, and we've got B, C, D down there. So that's G, A, E times, and then I've got to substitute the Christoffel symbol. But you'll notice the letters are different. It's not just an A, B, C. These are an E, B, C, D, so it's similar but not identical, so I've got to be a little bit careful. So this symbol here, which one is it? It's the top symbol, which is an E, and then here we've got an A and a C, which is the first and third, so that's a B and a D, comma B, which is the middle one, which is a C here. So we're differentiating with respect to B, which is the middle index, and the middle index here is a C, minus, it's the same superscript, A, B is the first two indices, which is B and C, differentiated with respect to C, which is the third index, which is a D, plus product symbol, minus the other product symbol. It's contracted on E again, E first position there. That D is the same as that. See, this is one of the reasons it's difficult. See, I've just casually written in an E, and I was about to say, because it doesn't matter what I call it, but I've got a free index here called an E as well. So I'm just going to get rid of that. Oops. I'm going to get rid of that, and that, and that. I've got to call it a different thing. I'm going to have to call it an F, and that's an F and an F. Now what's left? I've got an A and a C downstairs, which match these two indices here, which is B, C. That's an E and a B. That D there is that E. That D is the same as this one, so this one's the same as that one, which is an E. That's a B, which is the middle index here, which is a C. Which is C. Right, what have I got left? I've got A, B here, which are the first two indices on the low side there, so that's B and C, so that's B, C there and there. And we've got E and C here, E being the new, F is the new E, and C is the third index, and the third index here is a D. So I'll just put that D there, and we've got this nice expression. What I'm going to do is to expand. Let me just check I've got this right. We've got 4 downstairs indices, and here we've got we've got the E cancelling, we've got A, B, C, D, A, B, C, D. They're all in different orders, except that we're summing over E, and in this case we're summing over E and F. So we've always got 4 downstairs indices, because we've got 3 here and 1 from there, I guess. What I'm going to do is just have a look at these terms here. I'm going to ignore these. Really what I'm going to do is, well, let me just write out the formula that I've got. Let me just write the formula that I've got from my notes here. We've got R, A, B, C, D equals 1/2 of G, B, C, comma, D, A minus G, A, C, comma, D, B plus G, A, D. Of course, these are partial differentials. So this one here is die 2 G, B, C by die x d die xa. So it's a bit of a mess. Plus, what's this one here? That's GAD CB, comma CB, minus the fourth term, it could probably figure it out, BD, comma CA. Well, that's pretty bad. But we've also got cross terms here. We've got minus G superscript EF, and then some products of Christoffel symbols of the first kind. EAC FBD minus EAD FBC. Why is this form useful? This form's useful because the various symmetries of the Riemann-Christoffel tensor are very obvious in this format here. So what I'm going to do is, I'm not going to do all of it, but I'm just going to look at the first two here. As I say, I do feel marginally guilty because this is supposed to be general relativity step by step, and I'm just not going to do this. The thing is, it takes hours to do it, and it's very tedious and very error prone, as you'll see when I start to expand these terms here. So R, A, B, C, D equals, just read off this formula here, G, A, E times, it is, times this open bracket here, and I'll put the first term here, which is a half of die G by die X plus die G by die X minus die G by die X, yada, 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 yada. This thing here is supposed to be gamma EBD. I'll just mark that in red so I know what I'm doing. Just give me a second. Red. So this thing here, oops, that's supposed to be red. Let's try that again. Red. This thing here is that thing there. Okay, now we'll go back to black. Oh, let's try that again. Just a minute, it's there we go. Right, so EBD. So E on the top, BD. Oh, we've got to multiply by the Christoffel symbol outside. We've got an E on the top. Can we use F? I don't think I've used F. Oh, I've used an F here. Oh, it doesn't matter. I can use an F there as long as I remember it's different from these guys here. We're going to contract on an F. Where does the F appear? The F is there, or the first place, or the second place. What have I got left? I've got B and D. I can say B and D, or D and B, or B and D in the same place, and that's distinguished by having the second sign. Okay, so that's that term there done. Now I need, oh, and that's differentiated with respect to, oh no, that's the wrong place. It should be a subscript, just a minute. It should be a subscript C. What sign is it now? Minus G, E, F times, that should be a closed bracket there as well. Die G da da by die X da plus die G da da by die X da minus die G da da by die X da. And that is differentiated with respect to D. So it's EBCD. That is gamma E, B, C, comma D. So there's a comma D to match that D there. I've got my EF outside. I have. So we need, what have we got? We're going to contract F on the first place, F on the second place, F on the bottom. What have I got left? I've got B and C, which can go B and C, or C and B, or B and C. And this whole thing closes there because I'm multiplying the whole thing by GAE. Equals GAE times, I'm going to change my notation here, GEF times GFB comma D. I'm changing it just because it makes it easier. I'm used to writing down Christoffel symbols with Leibniz's notation here, but G, D, F, oops, I'm still writing the D because I'm copying it. G, D, F, comma B, minus G, B, D, comma F. And this is all differentiated with respect to C, minus G, E, F, times, actually that's a bracket as well, isn't it? G, E, F, G, F, B, comma C, plus G, C, F, comma B, minus G, B, C, comma F, dong, dong, comma D. Whew, what a mess. What a mess. So it's equal to G, A, E times, right, it's G, E, F, comma C times G, F, B, comma D plus G, D, F, comma B minus G, B, D, comma F plus, do you see what I'm doing? What I'm doing is I've got my two terms, that's U and that's V. So what I'm doing is using U, V dash equals U dash V plus U, V dash. That's all I'm doing. Plus G, E, F. You'll notice that I'm casually applying this law here in the presence of summation, which is quite a clever thing. There's quite a lot going on there. Times, G, F, B, comma, D, C, plus, because I'm differentiating with respect to D and then again with respect to C, G, D, F, comma, B, C, minus G, B, D, comma, F, C, I think that is. Yeah, let's get rid of this. Get rid of that. Can I close that bracket? Yeah, I can. And that's summed over F, which is in those positions there. Minus G, E, F, comma, D times G, F, B, comma, C plus G, C, F, comma, B minus G, B, C, comma, F plus, oh no, it's still a minus because it's the whole thing is minus, G, E, F times G, F, B, comma, C, D, because I've got a D here, plus G, C, F, comma, B, D, minus G, B, C, reading from here, comma, F, D, I think. There we go. Right, okay, so what have I done here? What I've done here is I have taken the first two terms, or the differential, the differential terms from a Riemann-Christoffel symbol, and I've taken account of those, but I'm not doing those. I haven't done those yet. Okay, you can see how hard this is getting. What will happen if I carry on expanding these terms and carry on manipulating them is I will eventually notice that various terms are going to cancel, and I can also start to use metric cancellation like that, because that's just a Kronecker delta with alpha and gamma. So by dint of noticing a large number of these very basic but fiddly identities, I can gradually manipulate my Riemann-Christoffel curvature tensor into this form here, which I'm not going to do step by step because it is incredibly tedious and boring and difficult and unedifying. It is not interesting or clever or helpful. You don't learn anything about tensor calculus, and you certainly don't learn anything about relativity from doing it. So I'm not going to do it. I'm going to stop there. Stop. I'm going to use this. I'm going to use this formula because this formula makes the various symmetries of the Riemann-Christoffel tensor very easy to see. So I'm going to use the formula, but I'm not going to derive it in detail because it's enough to drive you nuts. It's a dog's breakfast. And you'll see what a mess I've made of it already. That just gets worse and worse and worse and worse. Right, stop. Stop.